In this video, I'm going to give you some more detailed information about the base methods, what we call the base methods of an entity model. And we are going to be looking at the FEX radar class, which is the class that we've been using for most of these tutorial videos. For all these videos, we're assuming that you're doing the videos in the order that we recommend and that you've completed all the prerequisites. So you'll have this Visual Studio project already set up, and you'll have this tutorial project in here inside of this solution. So I'm going to go down here now to the source code of what we call the base class file, which is the file that is named with the I'm sorry, I'm in the wrong class here. It's EXM sensor that we're using as our tutorial. So here's EXM-SN. It's named with the class abbreviation. So this is the base class file, and it has in it the base class methods. So we've spent a lot of time talking about the class initialize function. So we're not going to go over that again, but we're going to take just a little bit closer look at the other functions that are in this file. And while we're doing this, we're going to pull up the definition of the class itself. So we're only going to be looking at the base methods. And again, these are the methods that are usually in this base file. So the first method that we're going to look at is the create method. So Forge does all the creation, Forge and Fire and other Flames applications. Forge calls create. It'll be unusual for any of your code to ever call the create method for any other object. Gets all the creation is handled automatically by Forge. But Forge has to know the pointer to that create function, and it has to be a function that it can call without having an instance of it. So in order to do that, during class initialization, we pass the pointer to that function into Flames, and we've already taken a look at that. That's this call right here. That actually saves the pointer to the create method in the default structure, which we've already passed to Flames. So that create function is a static function. And as you know in C++, static functions are functions that can get invoked without actually having an instance of the class available to invoke it. So whenever Flames has to create an instance of our class, or we're creating an instance of the class internally within our class, the create function gets called. So it's very simple. It just returns a new instance, and we use this operator right here, fnew. So I'm going to talk a little bit about that fnew operator. We define fnew in all of the C++ base classes. So all the abstract classes, the classes that you're going to inherit, that all these models inherit when they're being written in C++, there's an fnew operator, and that operator is very similar to the new operator. You can see how it expands. It's actually just a macro, and it expands to this. So we have another version of the new operator defined. The new operator expands to the same new operator, but it has a different argument. So we've overloaded the new operator. I'm going to come back to this a little bit and tell you what we're doing here, but I just want you to know we don't call new. You can call new right here, but if you do, you don't get some of the features of the Flames Memory Manager. So we're going to talk about memory management for just a second. When we do the new, the fnew, it actually invokes new, and when new gets called, of course, is standard for C++, we get the class constructor called. So the class constructor functions in Flames are always very simple. They're not a typical class constructor as you might see in most other C++ functions, if there is a constructor there at all, C++ classes. The default values and everything about our class have already been defined in class initialize. And we want to make sure that every instance of our class, every newly created instance, always gets all of those default values. So the way we make sure that happens is we take our default structure and we just copy it into this newly created object. So when when this constructor method gets called, the memory for our object has already been allocated. So then we invoke the constructor method for that newly created object for which the memory has already been allocated, and it's going to be passed in as this, so we have it there, and we just take the default structure and just copy the whole thing right in. This is what you will see in and only this for all, pretty much every single entity model. We have very few cases where there's additional code here. We just copy, so the constructor just copies in the default. And normally, the create method doesn't do anything other than just do a new, and it just returns it. So the class has been created, it's been fully initialized, the constructor has been called, and we just return it. There are some cases where additional substructures need to be allocated for objects, so all the memory of the object is not contiguous, and so you will see some additional memory allocation that is sometimes done in create. It's more often done in clone, and we'll talk about why we sometimes do it in clone instead of in create and we're going to do that in this video when we talk about the clone method. So let's go back now and talk about this new operator. Why do we overload the new operator here? Well, the reason we do that is because it's the Flames memory allocators that are being used automatically to allocate the memory for this object. And this passes in additional information into the memory allocators. And one of the things the memory allocators can do is keep up with the line of code where that object was allocated. So in the event that the memory for that object is corrupted in some way that the memory allocator is able to detect, the memory allocator will generate an error message, and the error message just won't simply say memory corrupted. It'll actually tell you where that particular memory was actually allocated. So it will do it by and we do that because we pass in this little standard C++ or standard C precompiler macro, which expands to line 74, and you can see 174, and see that's the line that we're on. So if there's something that happens relative to that memory, the memory allocator will tell us that memory was allocated on line 174. So that's all happens behind the scenes. It happens automatically. That is also used, by the way, for memory leak checking. So FlameForge has a built-in leak checking user interface. You can graphically go in and say, I want to check my application for leaks. We don't do that automatically all the time because leak checking is a rather CPU intensive operation. So we have a tool that lets us invoke leak checking automatically. And when we do that, if this memory didn't get freed correctly, so we have a memory leak, the error message that gets generated, or the message that gets generated from the leak report, will tell us that this memory did not get freed, and it'll tell us the exact line where that memory gets allocated. So it helps you find leaks very quickly. If you've ever tried to look for leaks, if you've ever suspected that your application had leaks in it, to try to find a memory leak can be really difficult. Most of the time it's a piece of cake with Flames because almost every place where we allocate memory, we are always passing in information about where the memory was allocated. So if it is not freed correctly, we can tell you where that memory was allocated. You can find your leaks pretty quickly. So that's create, and the constructor, as we've already talked about in another training video, we talked about when the clone method gets called, and we've talked about when the configure method gets called. So I'm not going to tell you about when they get called. We're just going to look at a little bit more detail about what happens inside of them. So configure is called when the overall scenario configures, as we've already explained in another video. This is the purpose of this function, is to check. You get a chance to check to see whether or not the input values that are stored in your class are values that you like. So this would be the values that are entered in the user interface as well as the values that are stored in the database when an object is read out of the database. The configure gets called in all of those cases, so you can get to check your values. And here we just have a couple of real simple things. We require the data processor to be set to something, and we require the max range to be set to something greater than 0. So I'm going to pull up Forge, and here's our user interface for our example sensor. If I type in a name here, create a data set, and I hit accept, and I don't specify the name, I'm getting this error message right here. It says no data processor specified. That message came from this line of code right here. We checked it. We don't want the data processor to be null, so we said, nope, sorry, we don't like that. And then we returned failure. By returning failure, we told Forge when it tried to configure this guy that we don't like the configuration of this object, and so we said this, and so Forge will put this message up and give the end user a chance to say, well, I know what I'm doing, I want to accept it anyway, or no, shoot, let me fix it first. So we'll go back to that. Similarly, in this case, let's put a value in there so it's happy. Now let's go set the max range to -1. I hit accept. Now I'm going to get this. Oh, and I can see that my error message is wrong. That's interesting. So I said max range must be specified. Well, I could do a better thing. I really could say that works. It's not a valid max range. It'd be better to say max range must be greater than 0. So actually, I'm going to change that. So if I fix that message, the next time I build Forge and everything, I would get that message coming out. So very simple. This is just silly, but it shows you the overall flow. Now let me show you what we do here. We don't just return failure right here, because if we did, we would only check one error condition, and the second one wouldn't get checked. So if the user had multiple things that were wrong about this, we wouldn't check all of them. But because of the way we do this, we just set this local variable and then we return it. Show you what happens if I go in here and I leave that wrong and I also leave that wrong. I'm going to get both messages. No data processor specified, max range must be specified. So that's the way we make sure that we get both of those messages, is we don't just return failure immediately. Now there's multiple return values that you can return from a configure method. Success means you like everything, it's good to go. Failure means you don't like it. And we'll tell you what happens if Flames gets a failure. We'll talk a little bit more about that in a second. If you're going to return failure, you should call FMH announce error, because announce error will actually create a message in the Flame status window that's in red. It's that announce error function that creates the red one. You may have a situation in your configure method where you can live with the value. It's usable, but it's probably not going to produce the results that the user intends. So in that case, you'd still return success, but you would generate a message, and the message would be announce warning. So warning means, not sure you really want to do this, but I will go ahead and run anyway. I can use this value. It's just probably not going to give you the results you expect. In the warning case, you wouldn't set failure. You'd just leave this as success. You'd call announce warning right here, and you would return success. So when Flames gets a successful return from a call to configure, but somewhere in that configure method, an FMH announce call was made, any kind of FMH announce call was made, the Flames will know that you had called FMH announce inside of your routine, and it will say, okay, this is a warning condition. So success condition is return success with no messages generated, no announce calls made. A warning condition is you return success, but you generated some messages. A failure condition is you return failure, and you should always generate some kind of message to let your end user know why it was that it failed. So that will cause Flames to put up the right error messages and display everything in Forge. You should be used to that by now. There's one other thing that I want to talk about configure. If you return failure from configure, and the end user accepts it, so you still get this, you still have a meta object that is that has values in it that you said that you don't like, that you're in your class you don't like. It'll still create that instance. It'll still save it in the manager, the respective manager, but Flames will not allow that object to be cloned. So if you return failure, you don't ever have to worry about the fact that somehow an instance of that object is going to get cloned and attached to your unit. And then you're going to have bad values inside your unit. Any value that you check and configure never has to be checked again if you return failure. Again, because it won't be allowed to clone. So let me just illustrate how that works. I'm going to go here and I'm going to make these values correct. So everything's fine, it accepted fine. I'm going to go to my units. I'm going to create a new unit. Data set, going to create a new unit right here. I'm going to go over to my script. I'm going to say employ sensor. And I'm going to go browse for that guy. I'm going to pick my sensor, put a semicolon at the end. I'm going to hit accept. Everything's fine. I go over here to my composition. I can see that an object has been attached. Everything's fine. Now let's go back to the sensor. Let's mess it up so it's not happy. I say I hit accept, and it says, are you sure you really want to do this? So let's say for some reason I really want to do this. I say yes, I do. So I get this error message when the entire scenario is configured after I hit accept. So there's my error message that comes up. But notice I get an additional error message. I get an error configuring unit, the unit that I have. That's this unit right here. I've got this script right here. It says employee statement error, could not attach sensor SDF to the unit. And you should know by looking at previous error messages why. Well, it's because that sensor didn't configure correctly. So so I go over to composition, there's no sensor there. So Flames did not allow that sensor to be cloned. If I go fix it, now everybody's happy. And I go back to my units window and click on it again, and there it is. So that's the configure method. Very, very powerful, very important, very helpful to your user that you write those configure methods right. You'll see that there's a lot more information in a lot of these configure methods. Some of them don't have anything because some of them don't have any user interface parameters, so there's nothing to configure. Let's go look at the configure method of this is still a very simple radar model, but we have a little bit more detailed configure method here in this guy. So this guy is doing quite a bit more. He is not only checking to see that the antenna actually exists, but he's actually going out or has been specified. He actually goes out to see that it exists. If it doesn't even exist, he tells the guy it's not there. If he then he checks to make sure it supports a certain interface. If it doesn't support the interface, it's not a sensor that we can, or an antenna that this sensor can use. So it makes that an error. Then it requires a data processor to be specified. And let me pull up Forge for just a second and go to the user interface for this guy. So he's got an antenna name and a data processor. It can't just put in any old value there. They have to be values that are legitimate by the configure method. So I've got a data processor name. It has to be specified. It has to actually exist. I go to the data processor manager. It has to support the right interface. So this is a little bit more detailed thing, but this makes sure that The particular objects that are specified are objects that I am going to be able to use in my processing. If they're not specified or they don't support the right interface, I tell the guy, sorry, you didn't compose that sensor correctly. I'm not going to run. So if when you clone this guy, when he gets cloned in the clone method, you'll see that well, we're going to talk about the clone method in a minute. So back to configure. So here's the configure method. Check it, make sure it's okay. So the next thing is clone. So we've already talked about in a previous video when clone gets called, we have an object passed in. So configure is only going to get called for meta objects. We never configure runtime objects because we don't have to configure them. The runtime object is always cloned from a meta object that has been configured successfully. So there's no reason to call configure for a runtime object. So this will always be a meta object that's being called, that this is being called for. Clone is also called for a meta object. And again, it's only called for meta objects that have configured successfully. So we already know here that the value, that all the values that we want are correct. So all we have to do is create a new instance of it and copy the meta object, which is this. Again, this is being invoked for a meta object. We just copy that whole thing into our new sensor. So we get an exact copy of the meta object. And that return meta object then gets attached to the unit. So that's what happens down inside of a clone method. Clone methods are usually pretty simple. They get a little bit more complicated though when there's additional things that need to be allocated and hung off of a particular object. So in the case of our FEX radar, as we just looked at in Forge, it uses an antenna, which is another object, and a data processor. Those are other entity models. So its clone method actually creates instances of those additional objects. So I go over here to its clone method, and you'll see here that I do my normal default behavior inside of a clone method, and I create a new instance and I copy it in. But then I go out and I go get the data processor that was specified, and you'll see here that I'm not checking the error return on that. We've already checked it in configure. So we just get it and then we try to clone it. So we call the clone method for that meta object. This is the same call that Flames makes when it clones things. We take the object that gets returned from that clone method and we save a pointer to it. Similarly for the antenna, we get its meta object, we clone it, and then we take the return from the clone, this newly created instance of the antenna, that a copy of that meta object, and we save a pointer to it. So these objects now belong to me. They're my unique copies of this object. And this clone method will automatically attach those objects straight to the unit as well. So I have a pointer to it and the unit will have a pointer to it. So if you looked in the composition of the unit, when you attach this guy and you employ that sensor, you'll get three objects. You'll get the sensor and you'll get the antenna and the data processor. So the unit will have three objects attached to it in its composition. Now you might ask, why don't we do this in the create method? Well, create, we can't do it because the create is always blank. We don't have any data to do this. We also don't do it during configure. You might say, well, why right here in configure, since we've done all this checking, why don't we just go ahead and clone these guys and attach it to the unit? Well, it's because this is being done for meta objects, and meta objects are not ever executed. So the meta objects don't ever need to have these sub objects because we're never going to be running. We never need them. So all we have to do is just check in configure that the right input data has been specified so we can clone them. And then we actually do the cloning in the configure, we do the cloning of the sub objects, the data processor and the antenna. We do that in the clone method. Now, because we ourselves have attached some additional objects to our our object, a data processor object and an antenna object, we have allocated those ourselves. We have to make sure that we destroy them when our object is destroyed. Now in our class destructor method, you'll notice that, right? You don't notice. Let me show you. The destructor method for our EXM sensor does nothing. Flames automatically allocates the memory for the entire object before it calls the constructor. It automatically frees the memory for the object after the destructor has been called. So normally we don't have to do anything because all the memory management is going to be handled by Flames. But in the case of the FEX radar, since we have ourselves in the clone method attached, done additional memory allocation by calling clone and attach those pointers, we have to make sure that we destroy it in our destructor. Otherwise, we're going to get memory leaks. And we always check to see if the value has been set, because what gets destroyed here could be a meta object, in which case the tracker won't be set. If what gets destroyed is a runtime object that had been cloned and attached to a unit, these values will be set, so we need to destroy them. And that entity destroy will ultimately end up calling the destructor and then actually freeing the memory of the object. So I've talked about the constructor, the destructor. We talked about class initialize in a different video. We talked about the create method. We talked about the configure method, and we talked about clone. Those are all the base methods of an entity model. And as we talked about before, pretty much every entity model that you ever see that comes from us, that comes from Turnion, or it's in the Turnion repositories, is going to have all these methods. They're all going to work the same way. You will rarely have to change any of those. If you copy one of the classes that comes from Turnion, and assuming, of course, that it's been implemented correctly, you'll get all this code already. You won't have to edit it and figure out how to type it all in. It's all going to be there. And you'll only have to change it as necessary for the ways that you're changing the class. So there's quite a bit of code here in these base methods. It's very, very important stuff, but it's stuff that's all set up automatically that you don't really have to ever, you don't have to make many changes to. So this concludes my explanation of the base methods of entity models. Thank you for listening, and thank you for using Flames.